and the standard deviation for each of these behaviors. So the mean is the average number of times we observe the behavior, and the standard deviation is the variability around that mean. And so the number of times someone scores above or below that mean is the standard deviation. And again, Excel will do all this math for you. You just have to just use some of the built-in equations that they've got. So to find the mean, it's actually just start to type in the average, and it comes up right here, E, average. Highlight that. And again, just going in and highlighting each of the columns that you're interested in looking at. This is K2 through O2, and hitting enter, and we see that the mean for running was 2. So that's sort of the average number of times that we observed jumping was 2 within that 9-minute, within those 3-minute segments. The child jumped on an average of at least 2 times within each of those 3-minute segments. And then to find the standard deviation, again, you just hit equals, start to type in ST, start to spell it out, and this actually will come up here, standard deviation. And again, highlighting this column, and then you see that their average number of times a child was observed jumping within each 3-minute segment was 2. But that varied about 0.7 around the mean. And so you kind of see that. We see, 2 times, the child was observed running. Well, I think I've been saying jumping. But, towards the end, we see a drop, and then we also see an increase. And so this is where you're seeing the variability around the mean for running. Now, for jumping, we'll do the same thing. Average, I'll do this quickly. 0.08 equals SD of standard deviation right there. Highlight that. Less variability, smaller mean as well. And so you see that we don't see any jumping in the first 3 minutes. We see jumping within the second 3 minutes, and then we see more jumping as the child moves into 9 minutes. Maybe they're getting bored running, and they're starting to jump more. And now within the 12 minutes between the next 3-minute mark, within the first from 9 minutes to 12 minutes, we see one more occasion of jumping, and then we don't see any more. And so that's why you kind of see there's really only 2. The mean is very small, and there's very little variability around that mean. And we're not really working with large numbers here either. I'll do the same thing here. That's median. Oh, wait, what am I doing? Sorry, average. Wait. And then standard deviation. And here's an interesting thing. You see we've got the same mean here for these two, for running and for sitting. We've got a 2. But the standard deviation is different. It's just a bit higher for sitting than it is for running. And you can kind of look at the numbers and kind of figure out why that's the case. So you see you have 3 2s, a 1, and a 3. So there's, like I said, there's very little variability around that 2, the average of 2 for running. But when you look at sitting, you've got a 3, you've got a 1, you've got a 2, you've got another 3, and then you've got another 1. So there's much more variability, even though the average number of times we see the behavior occurring is the same for running and sitting. The variability, the number of, if we're observing a lot of children, we could say some children's, that mean is much higher. And so, although on average we see sitting, within each of those 3-minute segment 2 times, whenever we were looking at that behavior, the likelihood is we will see much more variability, 3 here and a 1 here, a 2 here and a 3 here, and then a 1 within that behavior than the sort of more consistent running behavior, which we see a lot of 2s, and then we see 1 and a 3. Okay, so we'll talk much more about standard deviations and means in the next couple of weeks, but hopefully that was a helpful sort of introduction to that.